Microphone check, microphone check. Check, 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 check. Okay, class, so we are going to be doing section 1.2 now, domain and range. And again, these are our two learning objectives. And let's jump right in. So he's talking about domain and range mainly today. And domain, remember, domain was talking about the set of all inputs, and the range was talking about the set of all outputs. To talk about that, we need to use what's called interval notation. And it's pretty straightforward if you remember how to graph on a number line. So when I want to graph, if I want to say that x is greater than a, remember that's open here. You might learn it as an open dot, and it goes this way. Okay? And the way we write that with an inequality is saying x is greater than a. Now what might be new to you, some of you, is the interval notation, and the way we start with that is that just look at the number line. Okay, I'm starting at a, it's open, so it's a, and I want to go all the way over to the very end of the number line. Now there's no n, so we can just think of this as infinity over there, and so I go from a to infinity. So on a number line, infinity is over here and negative infinity is on the left. And if I do the same thing here, if I want to be less than a, again it's like open dot going over here. That means that the first thing I'm going to start with is actually negative infinity, the left of the number line, and then I'm going to end with a. Okay, and so if it helps you, you can draw your number lines with negative infinity on the left and infinity on the right to help you. And so if x is bigger than or equal to a, that means, again, if I'm starting at a, but I want to have a solid dot because it includes the number. Remember, if it has equal to, it means it can include a, whereas if it's open, it does not include a. So if I want to be bigger than a, this would be like this, like that. And here I want to be less than or equal to a, so I'm going to end at a, which means I'm going to start at negative infinity. So negative infinity to a. Now notice that infinities and negative infinities are always open. That's always the way it is. And then we'll continue. So I'm going to finish this out. So this is between a and b, so we write that as this. Okay, and again, they're both open between the two numbers. If I want to be less than, bigger than a, so again, closed bracket. And we call these open and closed. So this is closed right here, right there. We can do that. So that's a closed bracket, and then an open bracket is like this. Okay, all right. Let me get back to my pen. This will be open, closed. Remember, it's closed because it has equal sign. And so again, this interval is saying all numbers between a and b. I cannot include a, but I can include b. And if they're both equal, then we write it as a hard bracket, b hard bracket. Okay, and it's this number line with solid dots right there. Okay, all right. So why do we care about that? Well, we're going to care about that because we want to write a lot of things, like we're going to be talking about functions and stuff like that, and we want to talk about their domains and ranges and interval notation. And so when we talk about domains, we're going to be looking, we're going to be expressing our answers with intervals. So that's why we want to make sure we're okay with these intervals right here first. Okay. So now the main goal today is we're going to get practice with intervals on these problems, and we're going to use them to help us find domain. Now remember, the domain, the definition of a domain, is a set of all valid inputs. Okay, and usually those are x values. Just depends on the problem, what goes in the function in general. And so what we typically are going to do is actually we're going to look for where things can't be, because usually x can be whatever we want, except for when we're going to have trouble when we divide by 0. So we're going to set the anytime we have a denominator, we're going to set it equal to 0. Okay, and that's again because we can't divide by 0. Okay, if you divide by 0, it's undefined, so we can't include it. Also, anytime you have something inside of an even root, we have to set it greater than or equal to 0. Okay, and this is because we can't have even roots of negative numbers. Now, why is that? Well, remember, if we have, say, like square root of -1, okay, that's called I, and that's not a real number. It's a little bit beyond this section. Just remember that you can't put negatives inside of square roots. Okay, you can't put them in like a fourth root. If I had -1, okay, that's also not a real number. So in general, anytime you have a square root or fourth root or whatever, you can't put them inside a square root. So that's why we have to set the inside of an even root greater than or equal to 0. Now it can include 0, and we'll talk about that. Then once we do that, once we've got rid of all the restrictions, we'll express it as an interval. Okay. And if a function doesn't have any restrictions, if it's all good to go, I didn't have any division by 0 or any square roots in the problem, then the interval is going to be all real numbers, and the way we write that, the way we write that is, the way we write that is just like this. I messed up again. Is like this. Anyways, let's get some practice. We'll make it clearer. So let's find the domain of this guy. So here it's x squared minus 1. Now this is a parabola. Starts down here. Okay. And so on this problem, there's no denominators. And there's also no square roots. Okay, so because of that, that means there's going to be no restrictions. So no restrictions, no trouble spots. So x can be anything, can be any number, any real number. And so we write the domain then as all real numbers. Now the way you write all real numbers with interval notation is -infinity to infinity. Okay, and I'll write it in English. That's all real numbers. Okay? What do you think, Steph Curry? I think Steph Curry agrees, so he likes that. Okay. So, looking at this function here, what do you think about here? Are there any restrictions? Do we have any divisions on this function? Or do we have any square roots? I don't see any. And for us, that means that if there's no divisions and there's no way that I can divide by 0 here, and there's also no way I can put a negative inside of a square root. So the domain here is going to be the same thing. So there's no restrictions on this problem. So the domain for this one is the same thing. It's all real numbers. Okay? Moving right along. Okay, so what do you see if you're looking at this problem? That's our function. We want to find the domain for it. Do you see any trouble spots? And remember, what do we have to check? We have to check for denominators and for square roots. So hopefully you see that on this one we have a denominator right here. Okay, so there's going to be restriction coming from that. It's going to be a restriction. I could possibly divide by 0. And remember, we can't ever divide by 0 because it's undefined. Okay, so how do we find that restriction? Okay, the way you find it is by setting the denominator equal to 0. Okay? So for us, we'll set 2 minus x equal to 0, and we find out that x is equal to 2. Okay? Again, remember how you do that. You add x to both sides. Cancels out, and you're left with x equals 2. Okay, so what does this mean? Well, what this means is that if you plug that number 2 in, so if x is 2, if I plugged it in right there, 2 minus 2 would give me 0. And if I did that, I would be divided by 0. So I can't do that because, remember, nothing, when you divide any number by 0, it's undefined. It doesn't have any meaning. It doesn't exist. So what that means is that here, our restriction is x equals 2. So that means that our domain is going to be all numbers except x equals 2. Okay? Now that would be the answer. The domain would be all numbers except 2. Except that's really wordy, and it's like, has to write a lot, and math people we generally don't like to write at all. Okay? So the way we write is with interval notation. Okay? And so with interval notation, the way we write it is this. We say, okay, x can be anything excluding 2. So, and probably the easiest way to see why that works is that, okay, let's take a look at this interval right here. Let me use some room right here. If I plot this on the number line, get my little... Remember, here's infinity, here's negative infinity. Okay, say we have negative 1, 0, 1, 2, 3, 4, dot, 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 goes on forever. Okay, if I want all numbers except 2, that means I start at 2. It has to be an open dot right here. Okay, and it has to go this way and this way. Well, what does that mean? Well, that means x can be any number in here. It can be on this side. So how would I write the interval on the left side? Well, that interval, again, would be x can be anything from negative 2, which is, negative infinity, is right here, up to 2. So it goes from negative infinity to 2, and that's the first interval. The other interval is from 2 over to infinity. 2 to infinity, and that gives me this one. Okay? Now the way we write it is that, see how there's two intervals here? There's the left side and the right side. So this is the left interval over here, and this is the right interval over here. We just write both of them, and then we union it. So again, the way you would write this interval is you write the left interval first, and then you write the right interval. Okay? And then we use this symbol right here, and that's called the union symbol. Okay? Union means I want, union means I want both of these. Okay? So it's like an or. So it's like this interval or this interval. Either one. Both are okay. And so since my domain is all numbers except 2, the domain would be this interval, all numbers in here, less than 2, but also all numbers in here. And so that's why we have to union it to say or. So I want the left interval or the right interval. Okay, it's like it's like or. Okay, and that's called the union symbol, and you can type it in on Canvas and WebSign. If you just type in union, it will figure it out for you if you ever want to do an interval. Okay? All right. So that's that. So that's important. That's called the union. We're going to be doing that a lot this semester. Unioning, things like that. So And if you want extra practice, go ahead and try this problem. And I'm going to write the answer here after you hit pause. So he'll go ahead and pause and try to find the domain for that one. After you do it, I'm just going to write the answer and then move on from there. So go ahead and give that a try. Okay, and that's the answer for that function. X can't be half, and the reason I did that is I set this equal to 0. 2x minus 1 equals 0, which means that 2x equals 1, which means x is half. And so the restriction for that problem is right here. And if the restriction is half, then the interval, the way we write that is all numbers except half, which is right there. Okay. Let's go ahead and find the domain here. So for this problem, we have a square root. Now square roots, remember, can't be negative. So what we do is anytime you have a square root, you set the inside bigger than or equal to 0. And I want to stress this. You always do this for a radical, for a square root. You set the inside, not anything on the outside, but just the inside, bigger than or equal to 0. So for this problem, that means I'm going to be setting 7 take away x, has to be bigger than or equal to 0. Okay? And then you just solve it. So just add x to both sides. Cancels out. And then you're left with 7 is greater than or equal to x. Now that might be hard to read or to understand what that means. 7 is bigger than or equal to x. Well, what does that mean? Well, what that means is that the way I like to write it is actually the other way, and you don't have to do this, but I like to write it this way. X is less than or equal to 7. Like that. Okay? And I didn't change the answer. I just read it the other way. I said, okay, this also says x has to be less than, so it's x is smaller. See how the inequality is the the jagged part is next to the x. It's opening up to the 7, so 7 has to be bigger. And that's the same thing here. X is smaller than 7. 7 has to be bigger than x, or equal to. Now on a number line, what that looks like is this. Okay, I have, I'll put 7 in the middle, 8, 9, and we got infinity all the way over here, 6, 5, and negative infinity over here. Remember, negative infinity just means all the way to the left, so it's all as far as you can go to the left side, and the left side of the number line has negative, so that's why it's negative. And this is saying as big as you can get on the right. Okay, if I want to be less than or equal to 7, so let me get a different color here. Notice that it's a filled in dot. It's filled in because it has this equal sign, okay? And I want to be less than or equal to it, so that means I'm going to go, remember, x is less than 7, so I pick a number that's less than 7. 8's not less than 7, 6 is less than 7, so I go like this. Like that. Okay, so this is the number line way you write it. X is any number to the left of 7, including 7. And the way we write that as an interval, well, all you do is you just put negative infinity first, okay, and then you go up to 7. And see how, remember, it's open here. It's always open around infinity, and it's closed right here. Okay? So that's the interval. And the way I read it is x is between negative infinity and 7, including 7. Okay? All right. Don't worry so much about this table, this set builder notation. It's just your book does it a few times. Really just to get practice with saying, okay, here's a number line, here's the inequality, how would I write that as an interval? So please pause the video and come back and, well, first you write these inequalities as their intervals, like I did here for the first one. This says 5 is less than h is less than or equal to 10, okay? So that means it's going to be an open 5 and a closed 10. So please try it yourself. Try these 5 right here for me, okay? And pause the video, try to your answer, see what you get, and then come back and then I'll do them all. Okay. Well, that got erased. Okay, did y'all get the same answers here? So let's just make sure. This says that, again, it's between 5 and 10. Because it has the equal sign right here, that means it's a hard bracket. So hard bracket, open parentheses right there. And the rest of them are there. If you have any questions, let me know in on Canvas or anything. But these would be the intervals that we would be using. Okay, and yeah, so that's that. So remember, if it's a hard bracket, that means we have the equal sign, and it's open otherwise. And you know, if you're having trouble, remember that infinity is over here, and negative infinity is here. So that can help you. Okay. One special symbol is called all real numbers. It's got this fancy looking R right here. So if you see that, that just means that it's this interval, negative infinity to infinity, and it's all real numbers. Okay. So I'll do this one too. Okay, if I look at this interval, I see it goes, there's two parts to it. The first interval is right here, and the second interval is right here. So if I wanted to write this in interval notation, that would mean, okay, I got to go here and here. So let me write the first interval. It's between 1 and 3. And then I look at the dots, they're closed, so it means it's a hard bracket. Okay? And if I look here, it goes from 5 to 7. Okay? So that's 5 to 7. And this is an open dot, yeah? So that's going to be open. So that means it doesn't include 5. And this is going to go, oh, sorry, it goes past 7. So that would be infinity, actually. So, sorry about that. And it goes, so this arrow means it's going farther. So it's more. So that's why it goes to infinity, and that's why it's an open right there, open parentheses. And let me make that right. And because there's two intervals, we union it. Like that. Okay? Don't worry so much about set builder or inequality. I'll do it real quick. The inequality would be 1 less than or equal to x less than or equal to 3. And so union the other interval, which would be 5 less than x less than infinity. But we're mainly going to be using this interval notation. Okay? All right. So we have 2 more pages here. Okay? And so remember, domain is the set of all inputs. Okay? So whatever can go inside a function It's usually x is the domain, and whatever comes out is the range. Okay. When we have a graph, when we have a function, the easiest way to do it is just look at the graph. So here, let's get practice. The domain here, let's take a look. The smallest x value, well, the graph starts here at -5. So that means it's -5, and see why I wrote a closed bracket right there. And it's -5, and then where does it go? Well, if we keep on following it, put our finger on the graph, where does it go? Well, it goes, looks like it goes up until this vertical line here, and this vertical line is at x equals 5. Okay, so it looks like this thing goes until 5, and it's going to kind of stop. It can't get past this x equals 5. Well, that means we would just write it as 5. Okay, and it doesn't look like it ever touches it. It looks like it's going to approach it but never get there. So that means I would leave it as an open parentheses like that. So that's the inputs. The x's. Okay, so now what about the range? Oops. Okay, so remember the domain was the inputs. The range is just the outputs. So it goes. So the range is more talking about the up and down, whereas the domain is talking about the left and right. So left to right. Range is talking about up and down. Okay, so and the way we write it is actually we start with the bottom. Let me write it as bottom top. Oops. Okay. So it's actually bottom to top. Okay, bottom to top. What does that mean? Well, it's saying, look at your graph here, and let me erase this. This is not working. Okay. Where is the lowest that you go? Well, on this graph, the lowest it goes, and remember, this is like a number line, so I have negative infinity down here, and infinity right there. And if we look at this graph, again, we're going bottom to top, so the lowest it goes is, excuse me, this graph looks like it goes all the way down. It doesn't show it, but that arrow is telling us that it goes forever and ever and ever and ever. So if it goes all the way down as low as you can go, we call that negative infinity. And so this graph, the outputs start at negative infinity. So it goes all the way down. If the graph is going down forever, that means that the lowest it gets is negative infinity. Okay, remember it's open because it can never actually touch infinity. It just kind of gets there. And then we look at, okay, that's the lowest the graph went. Let's go up and down on the graph, and let's see the biggest it gets. Well, the biggest it gets is up to here. Okay, and so the biggest it gets, it looks like, is going to be this number right here. Okay, and the biggest number right there, that's, I'm trying to make it big for you, that's y equals 5. That's the biggest that graph gets. So it went all the way down as far as it can go, but it doesn't get past this value of y equals 5. And so that means that the top value is 5. And notice that it's going to be a hard bracket because it has that solid dot right there. Okay? So the way I would read this is that the y values, or the outputs of this graph, go from negative infinity, so all the way down, all the way up to the number 5, which is right here. This is the y value of number 5, and it includes it. Okay. So I want you to take a look at this graph, pause the video, and try to write the domain and range. And I'll come back and I'll have the answer here. Okay, all right, you guys back? So here's what I got for the domain. The domain, remember, this is left to right. And so I just look, what's the most left that I go on the graph? It's right here, and that x value is -3. So that's why I wrote 3, -3. And what's the farthest right I go? Well, it's up here to 1. Okay, and it's an open at -3 because I have this open dot. That's telling me the graph doesn't actually go through that spot. It's open. So that's why I wrote it as open parentheses for -3 right here. And this is a closed dot, sorry. And at 1, it's closed. So that's why it's a closed right there. So it's open and closed. Okay. Now what about the range? Well, remember, range is bottom to top. Okay. And the bottom, the lowest the graph goes is -4. It happens twice, here and here. Remember, it's the y value. Okay. And the biggest it gets is right here at y equals 0. And this was y equals -4. So that's why the lowest it got was y equals -4. The biggest it got was 0. And they're both closed because I kind of drew over it, but because right here this is a closed dot, so that's why it's -4 closed. And right here this is 0, and it does go through there, so that's why it's a closed. It doesn't go through it right here, but it does go through it right. So it doesn't go through it, I'll do a different color, here, but it does go through it right here. So that's a solid dot right there. So that's why it's -4 up to 0. Sorry, I keep hitting the wrong buttons. Okay. All right. So this part is not so important about the toolkit functions. I'm going to go ahead and I got this out of the book actually. So I want you to go ahead and just look these up in the book in section 1.2. Okay. And for instance, what I mean is just go ahead and for these functions, go ahead and write the domain. And the range. And I'll start you out on this one right here. The domain is going to be all real numbers. Excuse me. And the range, if you see, is the lowest it goes is 0. And the biggest it gets is infinity. Remember, it's top to bottom to top. So it starts at 0 and then it goes up to infinity. Okay. Anyways, you can fill all these out. Get practice just with the interval notation. They are in the book in section 1.2. Okay. And they're not so important that you know off the top of your head, but more just if you can look at a graph and figure out what the domains are. So you can look those up in section 1.2. Okay. All right. That's it. Thank you.